Welcome to Chemical Bonding. In this course, you'll learn why atoms combine, how ionic and covalent bonds form, and how to draw clear electron dot structures. The aim is simple: to make bonding questions feel logical, not confusing. Let's build that confidence step by step. We'll begin with the reason atoms bond and how valence electrons guide that process. From there, we'll study ionic and covalent bonding in detail. Finally, we'll look at coordinate bonding and practice ICSE style questions, so each concept builds naturally toward exam readiness. The best way to understand bonding is to start with the reason behind it. Atoms bond because they become more stable, usually by reaching a fuller outer shell. From that idea, the main bonding patterns become easier to follow. Atoms may lose or gain electrons to form ionic bonds, share electrons to form covalent bonds, or donate a pair of electrons to form coordinate bonds. Once these patterns are clear, ICSE questions become less about memorizing and more about explaining diagrams, comparing bonds, and justifying properties logically. Use this course according to your starting point. If you are new to bonding, begin at the start and move step by step, because later ideas depend on the basics. If you already know some chemistry, focus on weaker areas, but still revise Module 1 before moving into harder bonding topics. If you are advanced, use the later modules for comparison, revision, and exam practice. As you study, follow a simple routine: watch, pause, draw, solve, and review. Keep a bonding notebook for definitions, diagrams, exceptions, and reasoning answers. Here's the big question: if atoms are the building blocks of matter, why don't most of them stay alone? In this topic, we'll see that bonding is not random. Atoms combine because they move toward a more stable, complete outer shell. Atoms are the basic units involved in chemical reactions, but in nature, they usually do not remain isolated. Many atoms have incomplete outer electron shells, which makes them chemically reactive. Through bonding, they share, gain, or lose electrons to reach a more stable arrangement. That is how individual atoms combine to form familiar substances. Hydrogen and oxygen form water, sodium and chlorine form salt, oxygen atoms pair to form oxygen gas, and carbon and oxygen form carbon dioxide. Chemical bonding is the link between separate atoms and the matter we see and use every day. In chemistry, stability is closely linked to energy. A particle is more stable when it is at lower energy, like a boar resting in a valley instead of balancing on a hill. Unstable atoms have higher energy, so they are more likely to change or react. Bonding is one way atoms lower their energy and reach a more stable electron arrangement. Noble gases give us the clearest picture of chemical stability. They are in group 18 because their outer electron shells are already complete. Helium is stable with 2 electrons in its first shell. Neon and argon are stable with 8 electrons in their outer shells. Because their outer shells are complete, they have very little tendency to gain, lose, or share electrons, so they rarely bond. Many other atoms react in order to reach a similar noble gas arrangement. In other words, stability comes from reaching a lower energy electron pattern. The outermost shell of an atom is called the valence shell, and the electrons in it are called valence electrons. These electrons are especially important because they control how an atom bonds with other atoms. A complete outer shell gives stability. For the first shell, complete means 2 electrons, called a duplet. For most larger atoms, complete means 8 valence electrons, called an octet. If an atom does not already have a complete valence shell, it tends to gain, lose, or share electrons to reach one. Different atoms reach stability in different ways. Noble gases, like neon, already have complete outer shells, so they rarely react. Sodium has one outer electron, so losing it is easier than filling the whole shell. Chlorine has 7 valence electrons, so gaining one completes its outer shell. Hydrogen has only one shell and needs one more electron to fill it. Chemical bonds form when atoms move toward these more stable electron arrangements. There are three common routes to a stable outer shell. A metal atom, like sodium, can lose an electron and become a positive ion. A nonmetal, like chlorine, can gain an electron and become a negative ion. The opposite charges then attract, forming an ionic bond. But nonmetals do not always transfer electrons. Sometimes they share electrons, as hydrogen atoms do, forming a covalent bond. The method changes, but the goal remains the same, a more stable electron arrangement. The deeper reason behind bonding is energy. Separate atoms may be in a higher energy, less stable state. If coming together allows their electrons and nuclei to arrange in a lower energy way, a bond can form. This drop in energy matters because it means the bonded substance is more stable than the separate atoms. So, chemical bonding is not only about atoms wanting full shells. Full shells are a useful pattern, but true stability comes from lowering energy. Let's make that idea more concrete. Sodium has one outer electron it can give up, while chlorine needs one more electron, so they form sodium chloride. Hydrogen works differently. Two hydrogen atoms share electrons to form H, giving each atom a more stable arrangement. Oxygen atoms also share electrons, forming O. The details differ, but the pattern is the same. Bonding helps atoms reach a lower energy, more stable electron arrangement. When an ICSE question asks why atoms bond, keep your answer reason based. Start with the main idea: atoms bond to become stable. Then explain what stability means: a complete valence shell or a noble gas electronic configuration. Finally, state how they achieve it: by losing, gaining, or sharing valence electrons. Use terms like stable configuration, valence shell, and lower energy. A strong 2-mark answer is: atoms form bonds to attain a stable electronic configuration, like noble gases, by losing, gaining, or sharing electrons. Let's lock in the main idea. Chemical bonding happens because atoms become more stable. Noble gases are already stable because their outer shells are complete. Most other atoms have incomplete valence shells, so they lose, gain, or share electrons to reach a stable arrangement. Next, we'll use this foundation to understand valence electrons and valency.